Hello, everyone. Mr. Minnick's my name. Math is my game. I want to give a shout out to anybody who watches this back. I also want to give a shout out to my second period class. They're usually the ones that get to endure this grueling process of the first lesson of the day. Been at this for 15 years, maybe a little longer. But anyway, today we're looking at dividing polynomials. Dividing polynomials, Chapter 5, Section 4. Last Friday, my Algebra 2 classes were in groups, and they actually did this. So some of the stuff shouldn't be brand spanking new unless they weren't here on Friday. So I'd like to get some of the theory out of the way first. So again, the title is 5-4, Dividing Polynomials. So speaking of theory, I'm going to say let P of x, Q of x, R of x, and D of x be polynomials. Let P of x, Q of x, R of x, and D of x be polynomials. So Q of x is really what we're talking about in division. It's going to be our answer. And the answer when you divide is called the quotient. Let's see if anybody brought their A game today and can tell me what R of x is going to represent then. Meditation? Medication. It's a prescription. Not a prescription, no. It's part of the division process. Not the reciprocal. It's part of the division process. Nice. There it is. The remainder. The remainder. Okay. So let's see if we can figure out what D of x is. The part that you divide by, what's that called in division? Not divisible. It's divisor. Good. The divisor. Now the other part, the thing that you're actually dividing, is usually the dividend. But we already used the letter D, so I can't use it again. But P of x then is the dividend. Okay, the dividend. So I want to kind of take a look at the theory of this, how everything all fits together, but in the context of polynomials, just so we understand how to write our answer. So I'm going to go ahead and go split screen on this, and I just want to think about the number 86, and I'll divide 86 by 7, let's say. So 86 is our dividend. It's our dividend. And 7 is our divisor, right? And that's going to equal something. Is it 10 something? 11 something? I don't know. How many times does 7 go into 86? That's 1, that's 7, that's 1, that's 6, that's 2, it's 12 something. Right? 12 and what? 12 and 2/7. So 12 then, this 12 is our quotient, and 2 is our remainder. 2, that's our remainder. That's our remainder. And 7 was our divisor again. Divisor. And technically there's a plus sign there. So hopefully that's going to kind of help us craft our theory with P and Q and R and D. And so here it goes. If we take a polynomial P of x, so we're going to say that P of x divided by Q of x, nope, not Q of x, I'm sorry, that's a neck. I just necked myself. Divided by our divisor, divided by D of x. Maybe you'd rather write that P of x over D of x. Maybe you'd rather write it that way. So when we take a dividend and divide it by the divisor, we get our quotient. So we get our quotient. That's equal to q of x plus our remainder, so plus r of x over d of x. So this is the general form right here. Whoa, I don't know what I just did there. But this is the general form that our answer is going to have to be written in. When we divide polynomials, we're going to write our answer as the quotient. And if there is a remainder, it's going to be added at the end as a fraction. And the remainder will be in the numerator of the fraction. The denominator will be the original divisor. So I mentioned in my classes before we started this that there's going to be a quiz on this material. And one of the quiz questions is going to be to compare and contrast synthetic division with long division. So I'll just give you a few bullet points of information about long division. Okay? Some things about long division. There's an algorithm that repeats. So with long polynomial division, there's a repetitive algorithm. And that algorithm starts with one thing. I don't know why. It doesn't even matter how hard you try. It starts with division. And after you divide, you multiply. And after you multiply, you subtract. And after you subtract, you bring down. So it's an algorithm that's repeated over and over and over until the process is done. We're going to see later this week that with synthetic division, there's also a repetitive algorithm. It doesn't require the same four things, but there is a repetitive algorithm. Okay. Another thing about polynomial division is it takes up lot's two separate words, of space. Long polynomial division takes up a lot of space, a lot more than synthetic. One question is probably going to take up a third of a sheet of notebook paper. Synthetic division, one question shouldn't take up more than about 4 lines of notebook paper. So long division is going to take up space. The one nice advantage of long division is that the answer, remember the answer is really the quotient, the answer or the quotient will be clear. The answer will be clear. When we do the other type of division that we're going to do later this week, you're not going to know what the answer is right away. You're going to have to interpret your answer. But with this long polynomial division process, the answer is going to be very apparent. It's going to be very clear. One advantage of this over the other one is this works for any divisor. Later in the week, we're going to see that synthetic division is not going to work unless the divisor is of a particular form. Okay. I know right now some of this stuff probably seems a little vague because we haven't actually looked at an example, but it'll make sense later in the week. And maybe we'll review this material later in the week. The last thing I want to say is that with long polynomial division, keeping in mind I'm comparing it to synthetic polynomial division, escaped my mind. I just forgot. I had something in mind, and I totally forgot. Oh, it came back to me. You must use placeholders. You must use placeholders. That's going to be true of synthetic division as well. And there, I guess there's one more thing, arguably, that I could say. Alignment is critical. Alignment is crucial. It's real important to have things lined up in a particular fashion. In our first example, you'll see that. What I mean by alignment is having your quadratic terms in line with your quadratic terms, and your cubic terms in line with your cubic terms, and your linear terms in line with your linear terms, and so on. So we got the theory down. We got some bullet points about long division down. We know the algorithm. We know we're going to be dividing. We know we're going to be multiplying. We know we're going to be subtracting and bringing down. So I think it's time to look at an example, eh? So I think we're ready. Example 1. Use polynomial long division to divide this, our divisor, by this, our, I'm sorry. Dang it, that's another neck. I don't know if you heard that, but anyway, that's 2 necks. I'm going to blame it on the lack of coffee. So this is my dividend. This is my dividend. This is my divisor. So when it's all said and done, we're going to write up our answer in that form that we were looking at. So with division, we're going to need the long division bar. Some people, I saw somebody putting one of these things on. I don't, that's like a square root. I don't know how you want to make this thing, but anyway, it's the division bar. And our divisor, the x plus 5, our divisor, the x plus 5, is going to go in front of that division bar. And our dividend, the 4x squared plus 23x minus 16, that's going to go under the division bar. I don't know if anybody ever plans on taking an accounting class. I almost failed accounting because you have to be so precise with how you write things if you ever keep a written ledger. With this, it's good practice. Make sure that your alignment is real good. So step by step, I'm going to write down off to the margin what I do. The first thing I do is going to be my front end estimate. My front end estimate. That doesn't mean that a deer jumped out in front of me and I have to take my car down to the body shop. What I mean is I'm not looking at everything. People get overwhelmed because they look at everything. All I'm looking at is this. And I'm looking at this. All I'm looking at is the 4x squared and the x. So my front end estimate, what I'm really doing is I'm dividing 4x squared by x. What's that equal? Not going to be 4, or it is going to be 4. 4x, nice, good. So that's going to be 4x. So that 4x then is going to be written in a spot that is going to be right here. Now some people might write it above the x squared, but I said alignment's critical. I've seen some textbooks do this, and it's probably a really good idea to go ahead and put the linear terms in a line. So here's 4x. So write down this column is going to be all my linear terms. Okay? So that's the first step that I did, was that front end estimate. I divided, because that's the first step of division. If we look at the algorithm, the next step is to multiply. So the next thing I'm going to do is multiply. And this is where a lot of people get this twisted. Because I have 4x being multiplied by x plus 5, I have to use the distributive property. I have to use the distributive property. So I'm going to take 4x times x and 4x times 5. And that information is going to go right into there. Okay. So 4x times x then is going to be 4x squared. And 4x times 5 is going to be 20x. Now, I saw some people the other day ago when they were doing this, they're leaving out operators. Remember, polynomials have terms, and the terms are all separated by operations. In this case, we need an operator, and that operator is going to be the addition sign, so we'll have a plus right there. Okay, so that's my second step. If we look at the procedure, the third step is to subtract. So the third step is to subtract. So the third thing we're going to do is we're going to take 4x squared plus 23x plus 23x. We're going to subtract 4x squared plus 20x. We subtract. We subtract the whole thing. I like to use parentheses. Minus sign, like to put parentheses around that. So you don't have to, but it's a good idea too. It's a really good practice too. 4x squared minus 4x squared, those cancel. 23x minus 20x is going to be what? 3x. Good. 3x. Okay. So if we think about it, we divided, we multiplied, we subtracted. What's the next step in our process? Bringing down. So now we got to bring down. Bring down. In this case, the 16, the minus 16. So there's the minus 16. Remember earlier I said alignment's critical. Notice in that column, all our linear terms are there. Right? All our linear terms, all our constant terms, all in a line. Okay? Alignment's critical. Make sure you got everything lined up nice and neat. Question. What do I have written? Number 3, I took 4x squared plus 23x minus 4x squared plus 20x. It's essentially subtraction. Good question. Yeah, step 3 is the subtraction phase. So we said that this algorithm repeats. It starts over, right? So we got to start over again. Here's where people get confused on this. When we start over again, we're going to do the first thing again, which is going to be our front-end estimate. It's going to be our front-end estimate. We're going to be dividing. And in this case, what we're looking at is the 3x. And this isn't working out so well. So we're looking at that 3x there, and we're looking at that x there. So we're asking ourselves, how many times does 3x go into x? That's what we're doing. We're saying, what's 3x divided by x? What is 3x divided by x? 3, sure. So that's going to be 3. And that's what's going to end up going up there then. So we're going to put that 3 there. Now keep in mind, we're dealing with polynomials. Polynomials have terms. Terms are separated by operators. And that's a positive 3, so we do have to write the plus. So we've started over. We got our front-end estimate. That's our first step. Second step is going to be to multiply. Multiply. So we're going to take that 3, and we're going to multiply that 3 by the 3x minus 16. Okay. So we're going to be multiplying 3 by, I'm sorry, not by 3x minus 16, dang it. We're multiplying 3 by x plus 5. I'm sorry about that. So we're multiplying this 3 by the x plus 5. And that information is going to go right here. So 3 times x, of course, then is 3x. 3 times 5 is 15, and it's a plus 15. And then the third thing we're going to do is subtract. We're going to take 3x minus 16 and subtract 3x plus 15. And I got news for you. This is where a lot of people go wrong. People are lousy subtractors. Earlier I said it's a good idea to use parentheses. When you subtract this, let me go ahead and make this full page width. Start moving some of this stuff down out the way. Oh man. Oh man. Does anybody know what we're going to get when we do that subtracting? It's not going to be -1. Remember earlier I said use parentheses, right? We're subtracting the quantity 3x plus 15. 3x minus 3x, those are going to cancel. We have -16 and we're minusing 15. It's -16 minus 15. So what's that going to make? -16 minus 15. Say it loud, say it proud. Thank you. -31. -31. So, there's nothing else to bring down, and that's it. We're done. Kind of. That's it. We're done, kind of. So, -31's our remainder. Now, remember, we said P of x divided by d of x. Well, we better look at that. That was kind of confusing. We said P of x divided by d of x equals Q of x plus R of x over d of x. So expressing the answer this way with that remainder as a fraction added to the end, that's kind of important. That's kind of important. So our answer is going to be written like this. 4x plus 3 plus the remainder, which is -31, divided by the original divisor. What was our divisor? X plus 5. X plus 5. So that's it. This right here is our answer on that. I'll make that big for all the world to see. Our answer is 4x plus 3 plus -31 over x plus 5. What do we think of that first example? Yes, no? Makes sense? A little bit? We're going to try some more. Let's try another one. Oh, look at this. How many times does x minus 7 go into 3x squared minus 29x plus 56? Some people try to do the whole thing in one shot. Some people try to say, oh, well, it's going to be 3x minus 5. You don't know what it's going to be, so don't try to do the whole thing in one shot. Remember, it's a front-end estimate first. How many times does x go into 3x squared? How many times does x go into 3x squared? 3. 3 times x is 3x. We want, how about 3x? Is that going to get it done? So that'll be 3x squared minus 21x. It's a good idea to use parentheses when we subtract. It's a good idea to use parentheses when we subtract. 3x squared minus 3x squared, that's going to cancel. What's -29x minus 21x going to give us? -29x minus 21x. -8x. So it's going to be -8x. So we divided, we multiplied, we subtracted, we brought down. Now what? Start over. Front-end estimate again. This time we're looking at how many times does x go into -8x. Oh, we forgot something first, though. What did we forget? The 56, got to bring down that 56. So that 56 gets brought down plus 56. Okay, so now we're ready. X goes into -8x how many times? -8x divided by x. It's going to be -8. Good. So that's going to be a -8. So remember the process. It's divide, then multiply. So we're multiplying that -8 by these things out front, and that information is going to go down here. So I guess that's going to be -8x plus 56. Huh. It's kind of interesting. What happens when I subtract? They cancel. Everything cancels. What's my remainder? There isn't a remainder. This all cancels. So do I need to write plus 0 over x minus 7 then? No. So the cool thing is if there's no remainder, you don't need to write it. And then this right here is your answer. That's it. Now something very profound happens when the remainder is 0. If the remainder equals 0, then both the divisor and quotient are blank, 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 blank of the dividend. See if you can fill in the blanks there. If the remainder is 0, then both the divisor and the quotient are something of the dividend. Looking for an F word. Factors. 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 So if we were to take 3x minus 8 and x minus 7 and multiply those out, that's going to equal the dividend. Because that's how division works. So if the remainder is 0, then the divisor is a factor of the dividend, and so is the quotient. That's pretty awesome. Pretty cool stuff. I think we got one big example to try. You ready for it? A 0 remainder, that's a good thing. Getting a remainder of 0, that's awesome. That's kind of like opening a box of cereal and the prize is right there. Not having to dump out the whole box of cereal. So, problem 2. They want to know, is x squared plus 1 a factor of this? Wow. Man, this problem 2, it just went from kind of easy to opening up a new can of worms. Because there's a couple things going on in this. The question really should be written a different way. This question really should be written, is the remainder 0? Really, that's what this is asking. Is the remainder 0? Because if it is, then the answer is yes. Is the remainder 0? If the remainder is 0, then x squared plus 1 is a factor. So the insinuation, the implication here is that we're going to have to divide. Without asking us, they're really asking, is the remainder 0? Without telling us, they're really telling us, you're going to have to divide this. So divide and see what the remainder is. If the remainder is 0, the answer is yes. If the remainder is not 0, then the answer is no. So when I set this one up, I got to be very careful. When I put this divisor right here, I already screwed it up. Anybody see what I missed? What I screwed up? Maybe let's go back to the bullet points that I was talking about earlier, because I screwed something up. Let's look at the bullet points. The bullet points, you see the one under this works for any divisor? Let me highlight it. See this bullet point right here? Must use placeholders. Forgot about that. Must use placeholders. So let's see what that means. X squared is a quadratic, so that's okay. Plus 1, that's a constant term, that's okay. But what about my linear term? Do I have a linear term? Do I have any x's? I need a placeholder, and that placeholder is going to be plus 0x. Plus 0x. I need a placeholder. Okay. So the same kind of thing's going to happen with my dividend. 3x to the 4th is cool. Minus 4x to the 3rd is all right. Plus 12x squared is all right. And then what? Plus 5? Plus 0x. Plus 0x. And then plus 5. And then plus 5. So the first one we did was pretty easy. The second one we did was just about as easy. This one, Remember, it's the same process, but this one's a lot more difficult. Because on this one, I don't know if you can see, but we have a trinomial. And we're going to end up with a trinomial here. And then we got to subtract. You picking up what I'm putting down? So the first thing that we're going to do is divide. We're going to see how many times does x squared go into 3x to the fourth. So we're dividing 3x to the fourth by x squared. So what's that going to equal? 3x squared. Good. So we're going to go ahead and put in a 3x squared up top. So we divided. Now we're going to multiply. We're going to multiply this by this, and this, and this. And that's all going to go in where those purple parentheses are. So 3x squared times x squared is going to be 3x to the fourth. 3x squared times 0x is going to be 0x cubed. And 3x squared times 1 is going to be 3x squared. Now keep in mind we are subtracting. We are subtracting. The 3x to the fourths, they all cancel, don't they? Okay. So 3x to the fourths cancel. I have negative 4x cubed plus, minus no x cubed. So how many x cubes am I going to get? Negative 4 of them. Good. So that's going to be negative 4x cubed. 12x squared minus 3x squared. 9x squared, and it is going to be plus. Don't forget the operators. Plus 9x squared. So I subtracted. So we divided, we multiplied, we subtracted, and then what? Bring down. Got to bring down the 0x. Bring down the 0x. Plus 0x. Okay, so now we start this process all over again. We divide again. We don't bring down the 5, because the deal is we have out front here we got a trinomial, so we're going to end up with another trinomial right here again. Okay. Move part B out of the way for a minute. Maybe. Going to try to cover up part B. There we go. Cover up part B for a minute. Okay. So again, I'm dividing. It's a front-end estimate. I'm looking at this negative 4x cubed. Looking at this negative 4x cubed. I want to know how many times x squared goes into that. So essentially, I'm dividing negative 4x cubed by x squared. So what's that going to be? Yeah. Yeah, question. Wouldn't I bring the bottom number up to the top? I'm not following the question. Does the bottom number come up to the top? The bottom numbers from down here don't go up to the top. I think you might be thinking of the synthetic division property. I think you might be thinking of the last thing we did the other day with the synthetic division. And that's where we kind of bring those numbers up. We're going to do something like that with synthetic division. So let's go ahead and divide this out. What's negative 4x cubed divided by x squared? Negative 4x. So that's going to be negative 4x. So again, we multiply. So negative 4x times x squared is going to be negative 4x cubed. Negative 4x times 0x is going to be 0x squared. Negative 4x times 1 is going to be negative 4x. So now we're going to have to subtract. So we're subtracting that. Negative 4x cubed minus 4x cubed, those are going to cancel. 9x squared minus no x squared is going to leave 9x squared. 0x minus 4x is going to be plus 4x. Now up here we got We got a trinomial, and down here we're going to need a trinomial. So what's next? We got to bring down the 5. Bring down the plus 5. So now we do this again. The whole process starts over. Front-end estimate. What do we front-end estimate? We look to see how many times does x squared go into that. How many times does x squared go into 9x squared? X squared, how many times does it go into 9x squared? What's that going to be? Is it 9? So it's going to be plus 9. And again, we multiply now. Multiply that by that, that by that, that by that. We're going to multiply all that. So we're going to get another trinomial. 9 times x squared is 9x squared. 9 times 0x is 0x. 9 times 1 is 9. And we subtract. 9x squared minus 9x squared, those cancel. 4x minus nothing is 4x. 5 minus 9 is going to be, 5 minus 9 is going to be negative 4. So our remainder is 4x minus 4. So collectively, then our answer is this plus the remainder, 4x minus 4, over x squared plus 1, over x squared plus 1. But the question originally said, is that a factor of it? In other words, is the remainder 0? Well, is our remainder 0? No. So we did all that work just to be able to say that the answer is no. So our answer to this is no. And it's no because the remainder is not 0. I hope that you kind of have a general idea of how to divide polynomials now. I hope it makes a little bit of sense. I hope that you might be able to handle one like, got it, 2 part A. Just quickly to set that up, we would set up x to the 4th plus 0x cubed plus 0x squared plus 0x minus 1. We would be dividing that into x to the 5th plus 5x to the 4th plus 0x cubed plus 0x squared minus x minus 5. And we'd have to do that process twice and see if the remainder ends up being 0. What would the first term be in our quotient? We're looking how many times does x to the 4th go into x to the 5th? X times, or 1x times, right? So we'd have an x up here. So we would multiply this by boom, 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 boom. Multiply all that by all that. And that's going to take us all the way out to here then, when we do that. Right? So we'll have to do that process twice. So let's see, that's going to be x to the 5th plus 0x to the 4th plus 0x cubed plus 0x squared minus x. We subtract. These cancel. It's going to be 5x to the 4th plus 0x cubed plus 0x squared. I have minus x minus minus x. That's going to make plus 0x. And I do it again. I see how many times does x to the 4th go into 5x to the 4th. And that's going to be 5, so I would have plus 5. And I got to bring down the minus 5 there. So I do all that multiplying, and I get 5x to the 4th plus 0x cubed plus 0x squared plus 0x minus 5. And I subtract. And everything cancels. And there's no remainder. So I guess the answer to that one is yes, that is a factor. Wow. The process is the same. It's just you're working with polynomials. It's been fun. I hope it's been real fun. Have a great Monday. See you. Good.